Hello everyone. Today I am going to solve recent question paper of design and analysis of algorithms, and this question paper I found in Usmania University. So I specified here which year question paper and the details. Okay. So you know that we will be having short questions and long questions. I'll take at least 2-3 papers of previous years to cover all the important questions. Now here we go with this question paper is going to have two parts. As you know, the first part is short questions. This is for 2 marks. Okay, now so this is what the question up to here, all this is the question. The question is what? Derive the recurrence relation of the following algorithm. If you do not have an algorithm, also you can write an algorithm where the algorithm should be of recursive manner. You can take any of the example. So here there is no logic of this algorithm, like factorial algorithm will be differ to find factorial, and Fibonacci algorithm will be differ. So this is what recursive algorithm. That's it. There is no logic. Why should be it is m comma n minus 1 and why should be it is m comma n by 3. There is no specific logic why this algorithm is like this. This is a question. We have to answer this question to calculate the time complexity recurrence relation. Now, so before you go to the solution, please understand the question what it is first of all. We know already the time complexity is what? The time which is taken by the complete program, correct? So here T of n is equal to what? The total time complexity what this algorithm will takes. What this algorithm will takes? Here this step will take one amount of time, let's assume, and this step will take the other amount of time. So you have to calculate in that manner. Okay, now so I'll show the solution how it is. Here you did not find any else part, correct? I found only if block. I did not have any else part. So I'm going to write best case, I'm going to write recursive case. So what might be the best case? Best case is what? It occurs when n is less than or equal to 1. Here it is n greater than 1. If n value is greater 1, then we will be executing these many number of steps. Now best case would be, best case occurs when n less than or equal to 1. Now, however, the exact return or behavior for this case is not provided. So, I am assuming it is big O of 1 and T of n, the time complexity of this algorithm is equal to big O of 1 where n less than or equal to 1. So, this is what best case. Now, this part will helps you out to identify the best case time complexity of this algorithm. Did you understand? If this question is asked by the questioner in other way, that to find out the best time complexity, so then you can write this part of the answer. Okay, but the question is what? To find the recurrence relation. Now we will be having this recursive case. This recursive case is what? It is n greater than 1. Now there are two recursive calls in the algorithm. If n value is greater than 1, then I have to call the same function. I have to call the same function for 2 times. The one time is what? Foo m comma n minus 1 is the one function call, and the other function call is what? Foo m comma n by 3 multiplied by 2 is the other function call. So in recursive case, I have two function calls. Those are foo m comma n minus 1, foo m comma n by 3, which is multiplied by 2. Apart from the recursive calls, there is a for loop. There is a for loop which takes n comparisons. This time is what? N. Now the time complexity T of n can be expressed. The time for the recursive call is what? Foo m comma n minus 1 will take T of n minus 1, and twice the time for the recursive call foo m comma n by 3 is what? T, it is what? Generally T of n by 3, but it is multiplied by 2, so it is 2 into T of n by 3. Now the work done in the for loop is also part of the n greater than 1 recursive case. So that is big O of n. Now add these three. T of n minus 1 has to be added. 2 into T of n by 3 has to be added. Big O of n has to be added. If you add these three, that is the total time complexity. Or else the recurrence relation of the algorithm is what? T of n is equal to T of n minus 1 plus 2 into T of n by 3 plus big O of n. So this is what recurrence relation. Fine. Now we'll see the second question in the same question paper. The second question is what? They given a graph, connected graph. So in this graph you have to find out the BFS traversal. Now let's read the question for the better clarity. Write the order of nodes visited using BFS on the following graph starting from node A. Okay. Now, so this is your graph. Now, what is actually BFS? BFS stands for breadth first search. We will do two operations in BFS. One is visiting the node, the other one is exploration the node. Visiting is what? You are going to particular vertex. Exploration is what? Finding out the possible edges from this A. If you visited this A, you visited, first operation is done. Second is what? Exploration. That you have to find out the edges from this A. A is having edges of A to B and A to E. So exploration is what? Finding out the possible edges from the A. We have to do the traversing of BFS in this manner. Now, so initially we'll take a queue and visited arrays are empty. That means we'll take some visited array and we'll take this queue. Now, so what we'll do is, we will be starting with the vertex A. Fine. So when you are starting with vertex A, let's write here in queue which is A. Okay. Now my queue, I'm enqueuing or I'm inserting A into this queue. So after I inserted A, what I have to do? Exploration. What is exploration? Finding out the edges from A. So what edges A is having? A to B, A to E. Now you enqueue B comma E into the queue. So after you find the other edges B comma E, A has finished. Dequeue it. So after you dequeue this A from the queue, A will be inserted into array. So now how many vertices you visited? A only you visited. So let A will be here. Now come to this B comma E. So now Q is having B. So A has done. That means A is deleted from this queue. So this place is given occupied by B. So now B, E are in the queue. Now what you have to do? You have to identify the exploration of this B. What B exploration or what are the edges of this B? Find out. B is having C. That's it. B is having only C edge. That means C will be the here. So when C is here, B should be dequeue from the queue. That means B should be visited. Like this, you will be finding out the next thing. That means you have to find out the exploration of this E. Hence, you will find E to D edge. So D will be enqueued. Once after you finish your exploration part, you have to dequeue the other vertices. Finally, if you visited all the vertices, then entire queue will be empty. Whichever vertices you visited, that will be in visited array. Now find out the order of the visited vertices. Hence that will be A, B, E, C, D. Okay. So this is the way you have to write the BFS traversal. Now, right. Now this is what is C question. That means third question in the question paper. That is, explain how fractional Napso problem is solved using greedy approach. So in the classroom, you might have heard about how to solve the problem of Napso. Now here we will be going to see what to be right for the answer. Right? Now let's see. The fractional Napso problem is a classic optimization problem that can be solved efficiently using a greedy algorithm. So the reason I'm reading out my answer is what? It definitely helps you to write the answer in the examination point of view. It may helps you. I'm not advising you to write complete answer how I wrote. But my advice is what? If you consider this answer, then at least you can write few of the answer what I'm specified here. Done? Now, so what is fractional Napso? I have given the definition that it is what an optimization problem and it can be solved with the greedy approach. Now, this is what the problem statement. This you have to write. ఇది మీరు రాయకపోయినా పెద్ద నష్టం ఏం లేదు, ఇది మాత్రం ఖచ్చితంగా రాయాలి. Now what is this? We'll see. Problem statement. We were given a set of n items where each item I has a value vi and a weight wi. Now in your classroom maybe you taught with the word of profit, correct? Profit it is pi and weight it is wi. So here I am changing this term which is vi. Don't get confused. pi, vi both are means same. Pi means profit. I'm just terming vi, that is what value. I'm going to use profits with the term of value. So each item will have value and weight. Now a knapsack what can hold a maximum weight m, where m less than or equal to sum of all the weights of your items. The objective is to maximize the total value in the knapsack. But unlike the 0/1 knapsack problem, you can take fractions of an item. So this is what actually the one word answer. What is one word answer? Fractional knapsack problem will take fractions of the item. 0/1 knapsack problem in brute force approach, in other approaches will take 0 or 1. That means either object can be there or will not be there. That's it. That is, you can take any portion of an item rather than having to choose between taking all of it or none of it. This is what knapsack problem. Fractional knapsack problem definition, you have to write this much. Okay. Now, so how greedy approach will helps you out for the same problem? Greedy approach is what? The greedy strategy to solve the fractional knapsack problem involves the following steps. The first step is calculate the value to weight ratio, and this is the most confusion part maybe to the student. As soon as you found this fractional knapsack problem, you have to calculate p by w. It's not w by p. W by p kadu. P by w. Profit by weight ratio for each item. Then sort all the items by their value to weight ratio. Iteratively add items to the knapsack. This is what the approach. And the next question is what? Find out the time complexity of traveling salesperson using brute force approach. Here also I have to write the definition of the same traveling salesperson. Then we'll write this approach. So the traveling salesperson is a classic optimization problem where the goal is to find the shortest possible route that visits each city exactly once and returns to the origin city, otherwise original city or the starting city. Now how brute force approach is applicable on traveling salesperson? In brute force approach, we generate all possible permutations. It is important. All possible permutations of the cities representing different possible routes, and then compute the total distance for each permutation, the shortest of these distance solution to the traveling salesperson. Now the time complexity of this is what? Generating all permutations, the number of permutations of n cities is n factorial. However, because the starting city is fixed, to avoid duplicates, the number of permutations is n minus 1 factorial. Calculating the total distance for each permutation is requires big O of n operations. Now the time complexity is given by number of permutations or n minus 1 factorial. Distance calculation per permutation is big O of n. Now the overall is what? Big O of n into big O of n minus 1. Now So n into n minus 1, n into n factorial, and we will consider as big O of n factorial. Now, the other question. Explain the importance of principle of optimality in dynamic programming. So I advise all the students to remember one keyword about each question. Okay, 0 by 1 knapsack problem is either object will be there or may not be there. Fractional knapsack problem will take all fractions. Traveling salesman problem will take shortest path distance. Principle of optimality will take sequence of decisions. So like that, you please remember one keyword about each question, right? Now, the principle of optimality is a fundamental concept in dynamic programming, and it plays a crucial role in solving complex optimization problems efficiently. Definition is what? An optimal solution to any instance of an optimization problem is composed of optimal solution to its subproblems. This term is important, subproblems. In other words, if we break down a problem into smaller subproblems, solving these subproblems optimally will ensure that the overall problem is also solving optimally based on the decisions what we made in each stage. So the keyword is what I told you to remember, sequence of decisions. Sequence of decisions means what? You have to divide the problem into many subproblems. We'll take a decision here. We'll take a decision here. Out of this, whichever optimal, we'll take that decision. So this is what principle of optimality. The next question. Briefly describe graph coloring problem. So graph coloring problem is what? It is a classic problem in graph theory and optimization. It involves assigning colors to the vertices of a graph such that no two adjacent vertices share the same color. The goal is to minimize the number of colors used, known as the graph's chromatic number. Okay, now this is what the graph coloring. Now, vertices and edges. The graph consists of vertices connected by edges. Two vertices are adjacent if they are connected directly by an edge. Coloring is what? Assigning a color to each vertex. Valid color is what? A coloring is valid if no two adjacent vertices share the same color. Chromatic number is what? The minimum number of distinct colors are required to achieve a valid coloring of the graph. So this is what graph coloring problem. Now we'll see about G question, and this is what the last question of part A. This is what from the 5th unit. Define the terms of click and node cover. So what is a click? A click in an undirected graph is a subset of its vertices such that every two distinct vertices in the click are adjacent. That there is an edge connecting every pair of vertices in subset. In simpler terms, a click is a complete subgraph where all the vertices are connected to each other. Even this is also enough. మీరు ఒకవేళ ఈ పార్టే రాస్తామంటే కూడా ఓకే. You can write only these two lines for click. Not required to write a big paragraph. If you have any confusion, at least you can remember these two lines to write about it. So what is a click? It's a complete subgraph where all the vertices are connected to each other. Now, what is a maximum click? The largest possible click in a graph, that is a click with maximum number of vertices, is called as maximum click. So example, you can give any example. And now come to this node cover or vertex cover. A node cover or vertex cover in a graph is a set of vertices such that every edge in the graph is incident to at least one vertex in the set. Otherwise, in other words also you can say the same definition, which is every edge in the graph has at least one of its endpoints in the vertex cover. Here in this case also you can write these two lines. And minimum vertex cover is what? The smallest possible set of vertices that can cover all the edges in the graph. So this is what the definitions of node cover and click or click decision problem. So these are what 2 marks question. So I'll make the other video to explain you about long questions. Right? Thank you all.